Hey everybody, thank you for joining us today. Alex, I accidentally disconnected for a second. Can you make me a presenter again? Awesome. There we go. Thank you everybody for coming in today. I'm really excited about this webinar. When I first said I wanted to do my webinar on post-processed kinematics, nobody told me how much of a rabbit hole it was. And so I've spent the last couple of weeks diving in way more than I anticipated. And I'm excited to share with you guys what I've learned. So today I want to talk about what PPK is. We're basically going to do a what, a why, and then a how. But I want to talk about why it's important, why I think it could be something to consider for your photogrammetry workflows. We'll talk about some common misconceptions. And then I did some tests myself over the last couple of weeks in order to put together some workflow videos and compare data before and after post-processing is completed. I would like to compare the accuracies afterwards, and then we should have some time for questions at the end. Now, I do want to mention, originally I wanted to do this webinar on post-processed kinematics in general, and I still am doing that. But I found that I wasn't going to have enough time to fit the process for several different drone manufacturers into this one session. So I plan to revisit this with some other drone cameras, drone manufacturers, and stuff like that. And today I will be using my DJI Matrice 4 Enterprise for the demonstration portion of this. If you don't have a DJI Matrice 4, have some other DJIs, the workflow is all pretty similar. And I'd still encourage you to stick around because we'll be going over a lot of other stuff not specifically related to this manufacturer. And I do also want to mention that LiDAR is often used for post-processing, or I'm sorry, post-processing kinematics is often used for LiDAR workflows. But today I will be focusing on the photogrammetry side of it. So what is PPK? The basic definition of PPK is basically it's a method for correcting the geotags of your photos after you finish the mission. Post-processing kinematics is a processing method that achieves high accuracy positioning by correcting errors in the raw positioning data. Raw GNSS positioning, if you were to fly your drone without doing RTK or without PPK, we typically expect accuracies from under 1 meter sometimes, but as bad as up to about 5 meters away from the true position of the aircraft, which is not really good enough for situations where survey grade accuracy is a requirement. And this is why we use RTK a lot. I'm sure more of you guys are familiar with RTK workflows than PPK workflows. And that's because it's pretty simple to set up, and it improves the accuracy from that 2 to 5 or 1 to 5 meters down to 1 to 2 centimeters. But what really happens if you can't do RTK on a site, if you have a bad connection or something like that? That's kind of where PPK is going to come in, and so I'm excited to talk about that. But how does RTK actually improve our accuracies? Basically, RTK combines the raw GNSS data with corrections data that is streamed to your drone or your rover in real time. So when we connect our drones to a RTK source, whether it be a network correction service like TopNet Live or a Point One, or if we connect to the DJI base station, what we're doing is basically getting corrections from those sources and applying those corrections to the geotags of our photos in flight while we're collecting the data. Basically, these base stations don't move, and they know exactly where they are. And if they know where they are, then they know when the readings aren't showing exactly where they should be. And that's kind of how these corrections are calculated, is it's kind of a difference between where my base knows that it should be and where the data currently that it's getting from the satellites is telling that it is. And PPK basically does just the same thing, but instead of having a live connection to the internet or a live connection to your base station, if you have a DJI base station or something like an MLID, PPK is basically applying those corrections after we get back from the field and we're in the office getting ready to process everything. So RTK, it relies on a real-time stream, an unbroken stream of corrections data. And in PPK, we're basically applying it afterwards. Now, why does PPK matter? I know I kind of asked myself this for a while too, whenever I had a DJI base station, and I still have one, I still like it, it's convenient. But basically we need PPK or RTK because the raw data that our drone is collecting is just not accurate enough for survey grade deliverables. And RTK is accurate, but it is not always reliable. If you've worked with RTK for a long time, you may have come across a situation where you lost your fix for a little while. Maybe the drone went behind a hill or some trees, and you just lost connection for long enough to lose that GPS lock or that GNSS fixed position. I've also had my cell phone die while I was using it for the hotspot. It seems to drain battery pretty quickly. While I was flying with RTK, my phone powered off and then I lost my fix for the rest of the flight. I know some people forget to turn on RTK before they start their mission. It certainly never happened to me. And then there's all sorts of various other technical difficulties. But RTK in general is wonderful whenever it does work. But what happens when it doesn't? How can we plan for this or account for this? And what if our project is in an area where we literally don't have internet coverage or where we're not close enough to one of these base stations in order to get accurate RTK results? PPK can be a safety net actually. So for flights where you might lose connection, your fix might get dropped, or if you forget to turn on your RTK, no really need to fear. You can still go home with your data and go through the PPK process once you get back. So it can be a great safety net for RTK operations. And it can often be performed with some equipment that you may have already around the office, maybe some older receivers that could be gathering dust. But PPK is a great way to salvage the data in case of a RTK hiccup. And it can still correct the positioning of your photos within a couple of centimeters. And PPK kind of supports a better flexibility in the workflow. Instead of having to stress about RTK connection or enough batteries in your hotspots or your cell phones, you can focus on just collecting the data and worry about post-processing or worry about correcting it later. It can also be a little bit simpler, especially for sites where static is already being connected by other receivers just constantly. You can tap into that and pull data from there in order to correct your photos, instead of having to have a completely different setup for RTK or an online subscription service to provide that. So I did want to spend just a little bit of time talking about a couple common misconceptions. I think there was I put off looking into PPK for too long because I thought maybe I have RTK already, and so why would I need PPK? And then a month or two ago, I had, like I said, my phone died during an RTK mission, and it started to get the gears turning a little bit. So RTK is fantastic whenever it works well. But if a fix is lost during flight or a network service is unavailable at your project, say they're perhaps the nearest bases are too far away to get a really good fix, PPK is going to be really helpful to consider for these sorts of projects. I've also seen some rumors floating around that you do not need ground control when you're working with PPK. I've heard this about RTK too, and you may trust your workflow well enough eventually to ditch it, but in general, I can never really recommend using or going without ground control points for RTK or PPK when survey grade accuracy is a requirement. Ground control is just the simplest and most effective way we can verify our accuracies and also fine tune our data. So I would never recommend people use this without ground control points, or say that it negates the need for ground control points. Although if you've worked a lot with RTK, you know, sometimes you'll get within the survey grade tolerances and sometimes you may not, but you can never check that without using something. And then I also did have this one for a while. I thought PPK was expensive and for some more big budget companies or firms. And actually what I found out is that going through this whole process, most companies have an old GNSS receiver lying around somewhere, or you know, a couple extras or something you can multi-purpose if you're collecting static on your site already. And I will say I will be using the software Red Toolbox, and it certainly is more affordable than some N-trip services, RTK services, or even buying a specific base dedicated to RTK. I know some of the new ones come with RTK capabilities built in, but those are fewer and farther in between. And a lot of people do have something that can at least collect the static data needed for post-processing. And also, as far as PPK being expensive or only for big budget teams, if you lose an RTK fix during a flight and don't catch it, sometimes you can get away with it with some ground control points, but if it's bad enough, or if you lose fix for too long, it can actually cause someone to have to go back and refly the entire mission and keep a closer eye on their connection the whole time. So instead of having to worry about that, instead of having to send a crew maybe back out to a site, as extra hours spent, project delays, travel time, all that sort of stuff, I think that PPK could actually be something that could reduce costs in certain situations. But how do we do it? Well, I'm going to go over the tools that I use and the software I use, and then show a couple workflows, and we'll analyze the results afterwards. So like I mentioned earlier, I had originally wanted to do this on a bunch of different drone platforms, but I think I might have gotten a little overly ambitious. So like I said, this one I will be just using DJI Matrice for Enterprise. I also used some control points. These are arrow points in the background there. And I used the Futura F631 as my GNSS receiver. This one was nice because I was able to connect to, well, I was basically able to collect static, but I was also able to take measurements of my control points for this project. And I'll use these control points not as ground control points to anchor my map to specific coordinates. I will be using these to test the accuracy of my raw data. And then we're going to do a post-processing on the data set. And then we're going to look at the accuracies again. So these are checkpoints. We're going to calculate our RMES, or RM, root mean square error. Or it's on a different slide. I think I got that one right. Anyways, let's see here. And then for software, I will be using Red Toolbox by Redcatch. I believe they're a Swiss company, and they made this Red Toolbox for post-processing photogrammetry data. So it's got a lot of integrations with different platforms and payloads, and I've been really liking it. It makes things pretty simple, and they did give me a free 14-day trial. Well, you can just request one on their website. But I must say thank you to Red Toolbox for allowing free license. It was very nice to be able to test it out and use it for this webinar, and I'll probably be getting a full license here soon. And then for checking our accuracies, I use Pix4dmatic. You can use a lot of different photogrammetry softwares, but this one I had already, this one I already know how to use, and so I'll show the workflow real quick on how I use it to check my accuracies. So first is field setup. There was a little bit of preparation that I did for this. So my arrow points, I wanted to measure them with that F631 instead of relying on the GNSS unit inside, not because I don't trust it or anything like that, but because my subscription service ran out. And so I just measured them with my F631 receiver here instead, connected to an N-trip, and threw out 3 of them on my site and measured the centers of all of those targets, and we'll use them for accuracy. Once we got all of our ground control points set up, I then set my base station up on a known point in our front yard here at the office. That's the third picture. And basically set it up to start collecting static. Now, it is really important that you collect enough static for the PPK process to be realistically achievable. If you collect static for 5 minutes, then you fly your drone for 5 minutes and then tear it all down, there's not going to be enough overlapping data to compare between both sources to create a fix and fully synchronize the data between the different sources. So it's extremely important to leave the base station set up and collecting static for at least 10 minutes before you start the drone mission. It's really important for the drone mission to be 10 minutes long at least. And it's also extremely important to keep collecting static with your receiver for 10 minutes after the drone flight is done. In general, we're looking for 30 minutes at least of data collected with at least 10 minutes of drone data right there in the middle. And by comparing all of those, that's able to line up the data and give us a fix on all of the epochs or different seconds in our flight. So yeah, set it up for 10 minutes, fly the drone for at least 10 minutes, and then keep collecting for about 10 minutes. And then you can take everything down and head back to the office. You've got the data that you need. Now, what files do we actually need in order to go through this process? For the Matrice 4E and the drone files, they change a tiny bit depending on what drone you're working with. So just to focus on the UAV or the Matrice 4 for today, what we needed was the actual data, that is the photos from the autonomous mission. And the geotags, they're all geotagged automatically. So that's not something you have to worry about or set a setting for. And then you do also need a mark file or a trigger file, a .mrk. Basically what that is when the drone is flying the autonomous mission, it's collecting the raw GPS data and it's also flying its route and taking pictures. The mark file or the trigger file is basically a timestamp of every time that one of the photos was taken with extremely high accuracy in the time. And then it's also telling us a rough location of where that picture was taken. And then the other file we need is the UAV rover file or the observation file. For the Matrice 4, it's actually the .rtk file. And both the .mrk and the .rtk file are stored in the same folder as the photos when you're flying that autonomous mission. So they're all found right there together. But the RTK file or the UAV rover, the observation file, is just raw data that's been collected by the drone. So no corrections, just raw readings at times. And then by looking at the times the photos are taken in the mark file, we're able to combine those and see what the raw readings were at the point where each photo was taken. And then from my base station, mine created a bin or a binary file to start with, and so I just had to use a converter to turn it into my observation files. So from the base station, we need an observation file, which is, again, the raw readings of the satellite data, and then the base navigation file. This navigation file is kind of like has data regarding the satellite positions, their current orbits, and stuff like that. So combined with the observation file, we're able to get a better understanding of the GPS signals in the area, and we'll be able to compare them with the drone in order to calculate our differences. Now I'm going to show the red toolbox workflow first. I just took a quick video of it because I'm not good at multitasking. I can't really talk and click buttons in the software at the same time. So I took a video of this here. This is the red toolbox system. We just go into the post-processing setting, and there's a bunch of different presets in here for drones and payloads, manufacturers, that sort of stuff. But we're using the Matrice 4 today, so we'll just keep it set there. Oops, sorry guys. So we'll select the drone, and then we're going to do PPK correction. I actually found that doing no geoid instead of elliptical made my data come out a little bit more accurate after going through the process. So that's what I did for this video. And Red Toolbox has a nice feature where it'll kind of register one whole folder as the project. And so then it'll try its best to pick out the files you need, and you don't have to do quite as much rooting around in the file system to get your data. But once this all loads up here, we're going to go into our images and select the image folder just to make sure we've got the right mission. And then we'll go into our rover here. Now, under the rover is basically the drone. You've got your base, which stands still and collects raw data. And then you've got your rover, which is moving around and collecting data. But because it's moving, it's harder to get as precise of a position as something that sits still for 30 minutes. And that's why we use the base that sits still for 30 minutes to help correct this data. Now there's the mark file. Like I said, it's right inside of the drone mission folder. And then same with the observation file. If you see the DJI mission name right up there, data-ppk, that's just the folder that the drone created after I flew the mission. So it pulls it all in there. You just want to check and make sure that those the start and stop times are lining up. They usually do. I will say I don't know what happened. My SD card had a corruption, and so I did have to refly one of these missions, but it seems like maybe it was corrupted, or maybe switching it around between different systems screwed it up. Anyways, it's good to check that the time of the first image, the time of the last image, and then make sure that these first image timestamps and last image timestamps, all of that stuff is going over the exact same date and time roughly. And then once we've selected our RTK file, Red Toolbox converts it into an OBS file right there, switches from .rtk to .obs. But the observation start and stop time are still good. And then we go to our base station. We just pull the data from our static collection. That's my observation file right there. And it loads for a second. And then I do like to check the observation span right there as well, just to make sure it's all looking still good. Sorry, I can't not scroll with my middle mouse button. Yeah, there we go. So our observation file, just pull that right in, and then also our navigation file, or the data that shows what the satellite's orbits are and stuff like that. Now for this one, I did use the navigation file, that .25n, that is a GPS navigation file. I also did create a .25c, that's the Baidu constellation. That's China's GPS system, basically. And by selecting two of these in the navigation box, Red Toolbox actually just combines those two nav files together. So I can use data from both constellations to help improve the results. So it just combines them just like that, merged.nav. And then this is our output screen. So there's a lot of different options, but the top three, those are the ones that I've used here. That PDF report, once this whole process finishes, it's basically just going to give you some statistics about the different epochs, about all of the photos, you know, how many photos you got fixed, how many photos you didn't, and give you some data regarding that. Also, the the EXIF checkbox, that is basically going to take all of the photos that I put into this software, and it's going to create a new folder where the PPK solution that we find when we hit go is applied to the geotags of all of my photos. So if I leave that unchecked, I could overwrite my existing images by going to the bottom left, that optional if EXIF overwrite original image, but I want to keep my raw data too in case I need to go through this a couple times and play around with different data sets or make sure that my accuracies are where I want them to be. I don't really want to overwrite my raw data. So I check this EXIF on the top right. That'll rewrite the EXIF data with the corrections, but it will not overwrite. It will create a new folder. And then on the left, we've got image with a green check mark, rover with a green check mark, and base with a green check mark. That's a good sign. That means all of our time spans are overlapping. There's no software or file type issues that it's recognizing, and so it should let us process this and take a look at the results. So yeah, just make sure I'm creating a new folder, and then we will hit run and generate the output. Also at the bottom, that output folder, the project root folder, we can set it to put that copy of all of our photos with the corrected geotags in a couple different folders, depending on where we want it to go to. So on the right, it's basically, this is running through all of the epochs or short periods of time, and it's trying to get basically a fix or an RTK fix on each epoch of our flight. And then after that, the photos are lined up with each epoch from the mark file, and those corrections are applied to the geotags of the photo. So it basically tries to get a fix on the flight path first, and then using the timestamps of all of the photos, it's applying the corrected geotags to those photos that way. And this usually just takes a couple minutes. I found that it's able to get a fix on most of the epochs. I've seen this float section go down pretty low, but not to completely zero. But it's important to remember that we can get a fix on all of the photos, even if not necessarily all of our epochs are fixed, because the GPS position is applied based on the mark time of the photo. So maybe you have a section of your flight that's not fully fixed, but you didn't take a photo there. Maybe you'll get one or two photos that aren't fixed. It's not super important. There's a lot of photos in there, and as long as this doesn't look really red or bad or like fully orange and float, I feel pretty good about the results. Now I do want to go through just a quick workflow of how I do check my accuracies in Pix4Dmatic. Like I said, there's a lot of different softwares that you can do this in, but basically I just take, for this one, this is my raw UAV data. Basically just bring it into Pix4Dmatic, and then I'll import those control points. And guys, I'm sorry, we might go a couple minutes late, but this will be going up on YouTube. So if you do have to leave right at 1 minute from now, I won't hold it against you. I'll make sure this goes up on our channel as quickly as possible. Basically, I've loaded in my photos, and then I will load in my ground control points down here. And we'll just set up the coordinate system that we recorded our ground control points in, import the CSV file, and then, yeah, just pull up your coordinate system that the control points were recorded in. It must be the exact same one, or you'll have some problems and frustrations. Vertical coordinate system as well, I used NavD88 in US feed. And then we recorded them in GeoID 18. And my first point there is actually the known point that I set my base up for collecting static. And so I don't want to count that one. I just removed it. And then here, this is important. If you leave these types as GCP, when you go through the rest of this process, it's going to anchor your map to those GCP points. What we want is checkpoints. So what this does is it doesn't affect the position of my map at all. This will just calculate the error between where the center of my targets are and where I tell it the center of my targets are. So on the right side, you can see I'm just zooming in on each target. I just click the label number 2 or checkpoint number 2 here, and it pulls up all the photos that it thinks that that target will be found in. And then by going through and clicking the center where it actually is, I'm able to tell it, no, actually the center of this target is over here. And then by measuring the distance between those points, we're able to get our error. Now I did do this 10 times for each checkpoint, and I do have the whole video, and this video is already sped up, but I'm gonna just skip ahead a little bit. You guys get the gist of it. And once we get all 10 for each checkpoint, I've read 5 to 10 is probably about the right amount. We'll just go to the processing settings on the left up here. Should be almost there. There we go. And once we hit calibration and then start, it will start processing and calculating our root mean square errors here. So I'm gonna stop the video and go to the next slide where I show the accuracies both before and after the process. So I was actually surprised by how little off I was without using RTK or PPK. The first flight I did, I made sure I had my RTK module turned off and I didn't connect it to anything. So it was going just off of the raw data. And I expected it to be within a meter or two, but to see this mean checkpoint, root mean square error of 0.648 feet, I was initially concerned that I wasn't going to be able to make it any better with this process I didn't know yet. But after trying a couple different things, it did take a little bit of trial and error to arrive at the workflow we've shown today. Applying the PPK corrections, I did get my accuracy down to 0.133 feet. So this is about an 80% improvement in my accuracies from a flight that had no RTK or PPK to begin with and was already incredibly accurate. So that is that's the experiment. That's kind of the workflow, and I hope we have some time for questions. Alex, do we have questions?
Hey, Whit, great presentation. Yes, it does look
Thank
like
you.
we have a couple questions coming in through
Excellent.
here. Let's see here. Can I do PPK without a GNSS receiver?
Yes, yeah. I used our Futura F631 because it was handy and available, and I have people who can help me use it, and I actually learned how to use it for this project. But if you don't have a GNSS receiver lying around somewhere, the United States has what's called the CORS network. It's a continuously operated reference system is what CORS stands for. And basically all over the country, they have permanently set up stations operating constantly for decades at a time. And they record all of that data and post it publicly for anybody to download and use. Now, they are not covering the entire United States. If you look up a CORS network, C-O-R-S network, or CORS map, you should be able to find a map of where all of these stations are. But if you're not close enough to them, this data may be not close enough to your site to get improvement from going through the PPK process. But it's definitely worth checking because the data can be downloaded for free. You just have to make sure you select the right date and do the time zone changes, and then select what files you need. And if they're within the range of your site that you need, then it's going to be a great way to get into this, to get your feet wet. And if you find yourself on a site that's too far away from these permanent base stations, then you could grab a GNSS receiver down the road.
Awesome. One last question. How close to your site should a GNSS receiver be good for good results?
Oh, I should have answered that earlier. Ideally, it's recommended to be under about 6 miles for best results. I did do some testing with some data from CORS networks around our area, and I did still see improvement from a CORS station that was about 14 miles away. But in general, it's recommended to keep them within about 6 miles of you for best results.
Got it. Had some couple last minute questions. Are there any
Awesome.
specific computer requirements? Would ground control points in a calibrated site change your workflow, or static still necessary?
Yeah. Can you give me the first part and then the second part?
Yeah. So let's see. Are there any specific computer requirements?
No, not really. This red toolbox system is very unintensive on the hardware actually. So if you have something that's already able to stitch together your photogrammetry data, I would not expect you to have any problems with this. The software it runs very smoothly. So I haven't actually looked at the computer specs or requirements, but I don't anticipate that being a very large hurdle to overcome.
And then the other part of the question was, would ground control points in a calibrated site change your workflow, or static still necessary?
Yeah, so if we go back to where we were looking at my results, so doing the PPK process took my accuracy from, well, my error from 0.65 basically down to 0.13. That's without using any ground control points, and that is just about survey grade accuracy. If I had taken my 3 ground control point, or I'm sorry, my 3 checkpoints from this test, and then used the coordinates from those as ground control points to anchor my map to those targets, I would have gotten well under this survey grade accuracy. So I do think that using ground control points is still helpful. I used checkpoints, but once I checked my PPK process and made sure that applying the corrections improved this error, then I could go back and actually use those same ground control points. I would just rename them as ground control, and then I would recalibrate the scene. That's going to anchor my map to those targets, to those separately measured points, and we should get survey grade accuracy just by tightening it up a little bit more.
Perfect. One more question. Were the targets active or passive?
I'm assuming you mean were they turned on and collecting their own data? I was using arrow points, yes, but no, they were passive. My subscription ran out on the arrow points, and I haven't managed to get them re-upped yet. But I was just able to measure the center of those targets with my GNSS receiver in rover mode instead.
Perfect. I think that wraps it up. What?
All right. Well, thank you everybody so much for coming to join us today. Grab a picture of my email and phone number if you're working on a fun project or want to know more about PPK. I'd love to hear from you. And other than that, this video will be going up on our YouTube video, hopefully by the end of the day, or at least by the end of the week. So feel free to leave comments, leave questions there as well, and recommendations or requests for other content that we can put together. For now, thank you everybody for joining, and we'll see you next time.